Hello, everyone, and welcome to Insight Terra's first Data Dialogues webinar. We mean this to be a series which we have conversations with experts and thought leaders about how data is helping shape our world, and more specifically, how cutting-edge tools and technology are helping make a cleaner, safer planet. So today we're talking about the next generation of satellite technology and how it is transforming remote geomonitoring. We're looking at unlocking possibilities for environmental risk management. I'm Joni Watson, and I help Insight Terra with their marketing. Thank you so much for joining us. I know we've got people joining us from all around the world, as well as on the Zoom platform. I know that we have people streaming live through our YouTube channel, as well as LinkedIn Live. So hello, you all. Welcome. We're great to have you all here. Before we really get going, a few housekeeping bits. There's a live Q&A we're going to have later on in the session, but also if you have questions throughout this webinar, you'll see there's a Q&A tab. Feel free to write your questions in there. We'll either answer them written during the session, or we'll pull those out for the live Q&A session. And then we're also going to do a few polls. We're actually going to do a poll now. We would love to get to know our audience to make sure that we're pitching to the right level. So we would just love to know from what sector you're from. If you're a business leader, so you're interested in risk, maybe you're an engineer or technical consultant or something else. You could just... Okay, so... as expected, we've got people from all over the spectrum, lots of consultants, technical people, etc. So thank you for that. And then our next question before we get going is just to ask you what you see as your greatest barrier to geomonitoring today. Let's give a few seconds for some responses there. All of the above, yeah. That's great. So it looks like there are challenges and opportunities throughout the spectrum. So it gives me great pleasure to introduce you to our moderator of today's discussion. This is Dave Morris. He is industry expert, luminary veteran of the mining industry, and he has expertise in project management, M&A, environmental leadership, etc. He's also very passionate about sustainability, and he is a strategic advisor for Insight Terra. So I'm going to hand you over to Dave. Let's go.
Thanks, Joni. Thanks. And yeah, good afternoon, everybody, and welcome. And thanks for making the time to join us. I think it's a great opportunity to learn a little bit about what we do. As Joni mentioned, the purpose of the webinar is to share and highlight some of the latest developments in technology and real-time data management, which are becoming available through the advances in the use of satellites. We have some expert speakers lined up in the form of Jacques, and I don't know if he's going to put his camera on, Jacques, Keizo, and Alastair. And they'll provide some personal perspectives on how the advances in satellite technology and opening up new opportunities regarding data communications and sensing and real-time information platforms, and how we can use this technology in the future to move us really from passive monitoring into future possibilities of real-time preventative action. They'll speak about what's available now and what's emerging in what is really an exciting field. As Joni mentioned, I've had a working life in the mining industry, and risk has been very much part of the work we do there. It's currently I'm working with the Insight Terra team as part of their strategic advisory board. I think it's fair to say that satellites are no longer a scarce resource. They're becoming increasingly reliable, They're more cost effective as a means of digital communication, geomonitoring, and sensing. And in the last 5 years, it's been amazing to see the developments in the way that the technologies that are required to support satellites has emerged. I mean, the deployment of satellites has grown exponentially. And notably, I think the advances in launch vehicles, and that's something which we all keep our eyes on. But these developments, they provide an array of opportunities for, I think, new and inventive means of monitoring critical risks pertaining to industry, business, climate, and really much more. But the rate of change of technology, it's so fast that it's outstripped its adoption by business and industry. And I think there's a bit of catching up to do. My time in the mining industry involved the management of high value assets in projects, operations, and business unit management. And all of these were exposed to really a range of risks which had the potential to threaten the sustainability of the enterprise. A great deal of emphasis is placed on the management of these risks. And all major businesses and organizations, they now have a risk committee of the board and so on. But the actual effective management of risk actually takes place outside of the boardroom. And it's a complicated and complex undertaking, which remains a challenge for many companies. Events still happen and losses still result. My experience has really been that there's a high level of expertise in identifying hazards and the associated risks. But what's not so good is the design and implementation of effective and resilient control measures, and particularly the assurance that control measures are in place and remain effective over time. The non-availability of up-to-date current data and information is frequently a constraint to effective risk management. And especially it's a constraint to triggering the necessary interventions and actions which are needed when things are a little out of control. A common exposure that many organizations have is the time lag between monitoring, analysis, and the organizational response. This, in some cases, can be weeks or even months. And in the mining industry, failure to act timelessly when things are progressing out of control, it can have catastrophic results, failures of infrastructure, and they'll put the business out of action. I mean, there's recent examples of failures of waste storage facilities and pit slope failures, and it's not that uncommon in mining, unfortunately. So improving access to more granular data and real-time information, I think it offers the potential to transform approaches to risk management, making them more dynamic, more effective, cheaper, and in the end, it makes really, really good business sense. Using satellites in all their capabilities, along with terrestrial monitoring, that really presents the prospect for a step change in improvement to risk management, in its strategy, its organizational response, and also to accountabilities from operator all the way up to director. And there's some evidence that this is being adopted already, and the benefits are actually being harvested, but it's slow, and I think there's a lot more that can still be done. And I think, a final point from me by way of introduction is that there's always a counterpoint to risk, which is, I guess, it's opportunity. And I see a really big possibility to deploy real-time data in project planning and scheduling, and then also in business optimization processes where we can integrate in real time operational and financial data. And that's something which is rarely done at the moment. That's enough from me. So over to our first speaker. So our first speaker is Jacques West. Jacques is from Viasat, and he leads the strategic partnerships for Viasat, where he focuses on expanding satellite connectivity, particularly across Africa. He has deep experience in telecoms and digital infrastructure, and he's passionate about unlocking access to data that drives development, resilience, and innovation. So, Jacques, over to you, and maybe just by means of sort of getting going, I mean, my experience in the mining industry is that many critical industrial sites sit beyond traditional networks. So maybe you could share with us how Viasat is helping to close that gap and how non-terrestrial networks differ from traditional satellite systems, because I think, some of us perhaps not fully up to speed on that. So, Jacques, over to you.
Thank you, Dave. And I think to your point, when we talk about beyond the surface, what we're really talking about is the ability to see in real time, near real time, what's happening in places that matter most. For many critical sites like mines, energy facilities, dams, or agricultural zones, the biggest challenge isn't the sensors or the data itself. It's getting that data off site fast enough to act on it, having access to information more than delayed information. Connectivity is the foundation of environmental intelligence. Without it, data remains locked at the source, invisible and unusable when it matters most. So in context of a challenge, even today, a larger part of the world's surface remains outside of cellular and or other connectivity. And those uncovered regions are often the most important for safety, sustainability, and even climate monitoring. Let's call it the edge of industry where traditional infrastructure can't reach. For companies like Insight Terra and their partners, the gap between data collection and decision making is often a connectivity gap. If you can't reliably move sensor data from a tailings dam, a pipeline, or remote wind farm into an analytics platform in near real time, you're left reacting instead of preventing. Typical reactive versus proactive. So the question beckons how Viasat is closing the gap. At Viasat, our mission is simple: connect anyone, control anything, and secure everything. And we're achieving that through what we call non-terrestrial networks, or NTN, the satellite networks that extend the reach of mobile connectivity to wherever terrestrial networks stop. Today, we've already delivered what's known as NB-NTN, or narrowband non-terrestrial services. These enable small, efficient messages from IoT devices, the kind of low power sensors used in environmental and industrial monitoring, to transmit directly data via satellite. A great example is our IoT Nano service, which supports two-way messaging for industries like mining, agriculture, and utilities. It allows thousands of small devices to operate reliably, even in the most remote and rugged locations. We've already proven these capabilities across the globe through recent trials in India, the UAE, Brazil, and Europe, where ordinary standard-based devices have successfully connected over satellite networks without relying on towers or terrestrial backhaul. Looking ahead, the next generation, called near radio non-terrestrial networks, to throw in another acronym, NRNTN, will bring higher data capabilities, voice broadband, richer telemetry, and multimedia. These developments will turn connectivity into a seamless fabric that links every layer, from orbit to ground to cloud. I think the important point is that this isn't about building a closed proprietary system. We're working with global 3GPP standards, the same framework that powers 5G networks worldwide. This ensures interoperability and scalability so that partners like Insight Terra can integrate satellite and terrestrial data without worrying about compatibility or complexities. For Insight Terra's customers and partners, this means data continuity. No more blackouts or load shedding between site and platform. Imagine a mining operator who can see ground movement data from a remote tailings dam in near real time, and or agricultural company monitoring soil moisture across vast regions without depending on cell coverage. Connectivity is no longer the barrier. It becomes the bridge between sensing and understanding, between observation and prevention. There is, or put it these are not futuristic concepts. They are being deployed right now. And as the technology matures, costs will typically drop, devices will shrink with coverage that is already global. The combination of satellite and terrestrial networks, what could be called satellite ground fusion, is what will make environmental resilience practical and scalable. The future of monitoring and resilience will depend on a single truth. You can't act on what you can't see. At Viasat, our goal is to make the visibility universal, ensure the data can flow from the most remote sensors to the most advanced analytic platforms reliably and in real time. By fusing space and ground connectivity, we're helping partners like Insight Terra turn data into action, moving from monitoring what's happening to preventing what could happen. That's the future of connected resilience, and it's already happening. I hope that helps shine some light on how connectivity powers insights.
Yeah, thanks, thanks, Jacques. While you were talking, a question has popped up in the Q&A, and strangely enough, it was this question I was going to ask you as well. And as you were speaking, you mentioned connect, control, secure, and I think this relates to the question in the chat room. There's a concern around confidentiality of information, and you use words like universal visibility and so on. How does a potential customer, an end user, perhaps say a mine or a business, how can they be assured that all of their data is kept confidential, because some of it is really sensitive?
If the challenge with that, it's a fairly loaded question, as you know, from our side, and it is the part where the challenge comes in is ground network, towards the mine. But then you do get VPN infrastructure. It becomes a solution answer more than just a typical everything is encrypted. I mean, there's securities, there's encryption. If you think about Viasat itself, one of our business units is global government, where security and encryption is utmost importance. So I think it's a question that I would very much like to dig into, offline and unpack, the exact requirements for that. But obviously, in it is we constantly work on securing data, keeping it anonymous, keeping it within a closed environment.
So I guess then the short answer is it's not a concern. It's part and parcel of what you do.
Yes.
Right. Okay. Well, we're going to move on then to our next speaker. So our next speaker is Keizo Fujiwara, and Keizo is from a company called Synspective in Japan. And Keizo, I'm going to read some of his bio to you. He leads the global business development at Synspective, and they're a pioneering satellite data company using synthetic aperture radar. Can't say I'm quite sure what that is, to deliver actionable insights from space. He brings deep expertise in geospatial intelligence and international partnerships. He helps governments and industries harness satellite technologies for smarter and more resilient decision making. So Keizo, I mean, I know that Synspective have recently launched a constellation of satellites for Earth monitoring. What kind of data and observations are you getting, and what do you see as some of the applications for the use of this data? So over to you.
Yeah, thank you, Dave. Yes, we are launching and operating radar, more specifically, as you said, synthetic aperture radar satellites. So the satellite is, by moving on the orbit, it kind of synthesizes the radar antenna, so it can kind of get very precise data from the ground. And Strix is the name of our radar satellite constellation. And the unique advantage of the SAR satellite or these radar satellites is the ability to observe under any conditions, like most of any conditions, like day or night, cloudy or rainy conditions. And now we have launched 6 of them into the space and capturing high resolution radar data that allows us to observe how the Earth's surface changes over the time. And traditional radar satellites weighs tons, and our Strix weighs 1/10, like 100 to 200 kilogram range. And the cost is also 1/10 to 1/20th. So it allows us to launch many of them instead of like one expensive one. So, and we are targeting to have 30-ish constellation in a few years. And one of the advantages of the satellite-based observation is that we can observe large areas without placing a lot of devices. However, the frequency of the observation becomes often the problem because if there's only one satellite, it takes time to circulate the orbit and comes back to the same position. Usually, mining operators are interested in the particular site, some parts of the Earth, so that becomes an issue. And by increasing the number of the satellites drastically, we are trying to overcome the disadvantages. And yeah, Jack just talked about how ground-based monitoring systems and satellite communications are enabling real-time data transfer and analysis directly from mining sites. We share the same mission to make monitoring more accessible and continuous and data-driven. But our focus is from the space side. Not it's already a satellite. We don't need to. We can communicate with the ground already from the space, and using satellite radar and analytics to complement what's happening on the ground, creating a connected monitoring ecosystem that helps mining operators see the full picture in real time and at scale. That's what we are trying to achieve. And one of the most powerful tools, so like ways to use these SAR or synthetic aperture radar satellite, is so-called interferometric SAR analysis or INSAR analysis. So it's because it's a microwave. So if you carefully analyze the phase information, if you remember how the microwave is actually wave, so by carefully analyzing the property of it, it kind of allows us to quantify the ground movements, often up to the millimeter level, from the 500 to 600 kilometers away from the space. And this means that Insight can show how terrain around an open pit or tailing dam and other structures is shifting, even when it looks stable to our eyes. And because radar works day or night and through cloud, dust, or rain, we believe it's an ideal tool for the challenging environments like mining site. And at Synspective, we've developed strong INSA analytics expertise or capabilities system by processing data from multiple existing radar satellites while we are also building up our constellation. And we already provide such analytics that help detect subsidence, slope movement, and infrastructure deformation, supporting early action and safer operations of those construction operation companies. And our goal is to make these analytics as seamless as possible to more audiences, not only to the audiences who is expert in satellite or radar satellite, and provide easy access, integrate and interpret. So people who are good at the domain, like mining domain or like each specific domain can easily derive insights from satellite without too much concern about the satellite. And for applications, we see is like mining companies are already benefiting from INSA technologies. For tailing dam monitoring, INSA can detect small deformations in dam embankments or foundations, offering early warning of potential instability and complementing ground-based sensors. And pit wall slope stability. Regular INSA updates help identify areas of gradual movements in open pit or waste dumps, allowing for targeted inspections and safer operations. And subsidence monitoring for underground mines or dewatering areas. INSA can track regional surface subsidence across large distances or large areas, which is what the satellites are good at. Something ground instruments alone is not so easy to achieve or cover. And infrastructure management. INSA data also supports maintenance of haul roads, pipelines, and rail lines that may shift due to geological or hydrological activities. And operation monitoring, we also built a unique analysis technique, may uncover really large changes happening on the ground. So it lets management monitor if the operation is taking place as planned. And as our Strix constellation represents Synspective's own fleet of Expansar satellites designed for high resolution and all-weather imaging. And while full-scale INSA operations using Strix are still in development, we are already performing demonstrations and the validation projects with selected customers or partners. And as our constellation grows, Strix will deliver more frequent coverage and fast updates, bringing INSA insights even closer to near real time from the satellite's point of view. And it also enables detecting faster moving deformation, which was not possible with the satellites previously. Yeah, and we're also working with partners such as Insight Terra to integrate ground-based and satellite data, connecting sensor network and radar analytics and cloud system into a unified monitoring platform for mining operators to make a more comprehensive decision making.
Super. Okay, so thank you. I've got a few questions, but I think I'm going to go move on to our next speaker first, because I think we'll come back to them. We'll come back to them at the end. I'm sitting in the middle of a big thunderstorm here, so I'm really glad to hear your satellites are not weather dependent. Okay, so our next thing is we have a quick poll, which we'd like to do. So, Jenny, maybe you could just pop up the next poll, please. Okay, so here we have it. So it's the question is, where do you see the biggest lag between data collection and decision making right now? So if you could just pop your answers in there. And Jenny, maybe you could just give us the result, because I actually can't see that. Thanks.
Sure, people are still responding, but give it another 2 seconds. You know what? The 50% of the people that have responded say that saying that sorry, my brain stopped working. Saying that getting the right people to pay attention and take action is the thing that is their biggest lag. 36% of our attendees say analysis time, so turning raw data into actionable insights. And then 14% aren't getting access to their data fast enough.
Great. Okay. Thank you very much. Right. I think, Alastair, that gives us a nice lead into what you have to say. So our last speaker is Alastair Bovim, and Alastair is the CEO of Insight Terra, and he's the co-founder as well. And with a background in technology and sustainability, Alastair has a passion really for harnessing real-time data, as I've got to know, and also to protect communities and to drive climate resilience across industries. So welcome, Alastair. And you know, in conversations that you've had with me, you've often described the Insight platform as creating a system reflex, a monitoring ecosystem that senses and reacts automatically. So for the engineers here today, maybe you could start by describing, how does that really work, and when you're combining ground and satellite data, and especially when, at the moment, as Keizo kind of intimated, that revisit rates are still relatively infrequent.
Thanks, Dave. And I think just one thing to mention just about Viasat and their network, they actually have a constellation of L-band satellites, which also work very reliably in bad weather. So their network was actually originally designed for emergency distress for ships, and to make sure that the signals got out even in bad storms. So maybe you need something like that, Dave, in Johannesburg. Yeah, but just kind of get to your question, the ground the in situ instruments, are like the pulse of the monitoring. They give us that minute by minute measurements, but the challenge is their spatial coverage is quite limited. The advantage of INSAR, for me, that's like the ECG of your body scan. It gives you a snapshot of your entire site or your infrastructure. Very powerful, but it's periodic. So if we can combine these technologies, we can get a much better combined truth. Where ground instruments tell you what's happening where you measure, INSAR tells you where things are happening where you maybe didn't measure. So I think the opportunity now and in the future is aligning these technologies and the data sources so that we can bring them together so we can then act and respond faster. And that's where the reflex comes into it, right? Viasat provides the nervous system, Synspective provides the remote sensing, the eyes, and Insight Terra is the brain that brings it all together so that it can be, the reflexes can be invoked.
So there's data that comes in really from many sources, ground, satellites, plant, and I guess even there's manual data as well. So how does the Insight platform sort of ensure the quality of data and the cadence? How do you know that that's maintained? Quality of data is, it's always a cause for concern.
I think, Dave, you addressed one of the first challenges that we find in most projects is getting the reliable, consistent data, and that's the first goal. So part of what we do is we monitor every single instrument and every component in the monitoring infrastructure. Each one has its own operating state where we monitor in real time the health, the connectivity, the data quality. Think of it as a heartbeat of the monitoring infrastructure. And this is really critical to bring about reliable data, and so to ensure that calculations and safety monitoring is happening on trusted data. And that also has the benefit of reducing false positives. And it's often one of the most critical things to get right first is to make sure that the monitoring infrastructure is healthy, it's maintained, and supports the right information.
Put my microphone on. So once the data is validated, so how does that kind of support engineers in their day-to-day work? I mean, what can they do with it? Data on its own is fine, but we need more than this data.
Well, effectively, it's an old cliche, but it's where you turn data into information into knowledge into wisdom and action. So really, where our platform really starts to shine is when we bring all this data together. We have a safety monitoring module which kicks in. It's a rule-based quantitative implementation of the trigger action response plan. So think about a digital implementation of all the actions, and we continuously evaluate safety conditions with every single measurement received from every single device, and these thresholds are tied to the critical controls, for example, such as phreatic surface elevation or displacement acceleration or pore pressure rise. And these are mapped to the failure modes, and then they drive events and notifications to the responsible engineers, the people on site or the people at head office. And this really results in the real-time assessment of those critical controls, getting the right people notified so they can act proactively and prevent failure.
So that really answers, I think, the 3 points in the poll where people had some concerns around, the people, the action, and the access to the data. Maybe can you give us an example, concrete, real example of how this all comes together and is working on the ground?
But at a particular site a couple of years ago, actually, also in the northern part of South Africa, the safety state was triggered, and a top event was triggered to the people on site, and a phreatic surface elevation was detected over a line of piezometers. It flagged the anomaly or the rate of rise. And it prompted an investigation on site, and they discovered some teams were doing drain cleaning, so they were pumping water onto the embankment, which was not the right thing to do. They were stopped. Corrective actions were put in place, and the teams on site said if they didn't have the system in place, this would have gone undetected and maybe detected a couple of months later reactively, which would be too late to potentially understand that this was the root cause. So, this really illustrates the point of proactive approach and linking the investigation and the cause with corrective actions.
So, if you look ahead now to what's coming in the future, I mean, the one aspect is Synspective's expanded Citrix network. I mean, that's going to be operational soon. What changes do you envisage that's going to bring to this space?
Well, I think the key is Synspective's high frequency constellations will bring about almost daily visits to the site, as Keizo was mentioning. So the temporal granularity will really increase, will reduce latency to process data, better quality data, and then fusing that with more instrumentation data. So I think that'll allow SAR and INSAR data to be used far more proactively. So it'll be almost like seeing your facility or your infrastructure breathe, right? You'll be able to combine remote sensing with the live data and have a real living digital twin, not just monitoring, but actually forecasting behavior.
So, I mean, there's a whole lot more data that's going to be coming in real time. I guess connectivity is really critical when something like this happens. Comments on that?
Absolutely. And I mean, we see in many locations, and I think I'll try and address one of the earlier questions, connectivity is the key to the nervous system. And just imagine a future where every device can connect to a satellite directly, which can improve installation time, it can improve uptime, make it very simple. And we're already seeing sensors and instrumentation providers connect their equipment via satellite. Actually, there's a couple on the call. And we're already seeing water instruments, GNSS stations, and battery-powered AI cameras connecting via satellite. It's really, the future is happening, and I think it'll just become far more scalable in the future. And so it's exciting time to see more and more data, and it's going to make, I think, the impact for the engineers who need to make decisions on the data.
Well, I mean, things are evolving quickly. Is there any final thoughts really for the engineers and perhaps the business managers that we might have, on the call? Any big takeaways for them?
Look, I think the key lesson over the last 5 years we've been really involved in geotechnical monitoring is the people are important. So technology by itself, processes by itself, it's really a collaboration between technology, between the stakeholders, vendors, partners. And automation is not replacing judgment. It's really about amplifying that judgment and supporting that judgment. So it's going to be an exciting couple of years where we're seeing digital twins and digital tops really becoming part of a proactive management system rather than a reactive management system. So it's all about the people. We have to collaborate and coordinate and work together to make it work.
Great. Okay. Right. We've got a bit of time for some Q&A now. Let's have a quick look in the Q&A, what we've got. There was a question, not quite sure where it's gone, around cost. It's a question that I have as well, is that, this is, at the moment, it does seem rather a costly technology. What's the view on that?
So I think it gets quite a broad question, and there's ways to respond to that. It really depends on how much is being deployed and the risks being assessed. But effectively, we're seeing both from a satellite connectivity and a SAR perspective that costs are with scale becoming more effective. I don't know if you want to jump in, Keizo.
I see Jacques has posted an answer to that in the chat room as well. Another question, and I think probably this is one which would be for Jacques and/or Alastair. How does the system combine with drone surveys?
So I'll take that, Jacques.
Good.
Yeah, so we can take the output of drone surveys. It's another contextual layer. So if there's cloud point data that could be pulled into the system and then combined with both SAR, ground truth instrumentation. So especially if you've got bathymetric surveys or other LiDAR type surveys.
Just to add to that, from a connectivity perspective, we do provide connectivity for drones to help get that data to Insight Terra's platform.
So Jacques, if I understand it, that's something which is existing already and used.
Yes.
Okay, here's another question that's popped up. And this is one which I can align with. Is there a risk of too much data confusing the system? Isn't there a risk of information overload? That's in the real world of work. That is a really good question.
No, I think it's a very valid question. I think that's why it's also very important with the engineers to really, with the outcome of the risk assessment and the critical controls, line up with the data that feeds those controls and drives those controls. And part of our approach and our safety state is to simplify all the complex data so that engineers can focus their attention to the things that are key. But it's really mapping those critical controls, failure modes to the data sources. And that's really a big part of what the platform looks to achieve, is to simplify the complexity.
There's another question which is a little bit related to that, and it was kind of borne out in the poll that there's a lot of end user interaction needed to make the best of a platform such as the Insight platform. What should end users expect to commit to for successful implementation of a system that might have all aspects here? We've got some really good satellite sensing data coming in. We've got great communications with satellite, but how does an end user actually, what skills, what do they need to make something like this successful?
I think there's three parts to that question, Dave. One, to make any system work, it's the people, so it's training, it's engagement, it's buy-in to use the system. It's the processes, so tying it up. So tailings management is a life cycle, there's processes, and embedding the people, the behaviors with the processes. So I think that's a key element. And the other would be really coordination. It's especially in the tailings dam area, it's a living dynamic. Each site is unique, each facility is unique. And it's making sure that there's strong engagement and collaboration. In the facilities that we're part of, I think collaboration is the key. that's the absolute key ingredient to make things successful.
This that points to there being quite a big change management component of any implementation. From the implementations that Insight has done to date, would you have any sort of key takeaways for how that change management should best be handled from a user perspective?
It's really, I would say, getting stakeholders and sharing. So I think one of the good examples where engineers from different sites can come together regularly to share experiences across different sites. So implementing best practices, knowledge sharing, those come to mind, and also bringing in outside expertise to evaluate and validate.
Right.
See, we've even got an agricultural question popping up.
Yes, there's an interesting question about agriculture. It says, I'll read the question, and then I think maybe this is something that you could perhaps respond to, Keizo. An agricultural risk monitoring system would require monitoring over a wide geographical area, making ground sensors impractical. What form will a risk monitoring system take to overcome this challenge?
Yeah, so maybe this risk, if I try to guess, like it's more about the effect or impact to the like agricultural, like crops and those agriculture activities, then probably that is more suitable. I mean, optical or hyperspectral type of like a sensors which can capture like light or from those agriculture crops is more appropriate. That's my guess. And our radar satellite is more suitable for observing the shapes or kind of like a movement, subtle movement. So yeah, that's I think that's yeah the
Yep.
yeah,
Alastair, do you want to
application.
add to that? Yeah.
Yeah, so perhaps to add to that, I mean, as Keizo mentioned, you could be using optical imagery to look at crop health, crop growth days, for example, as well as soil moisture. So, and actually, we're doing this type of activity in some agricultural use cases where we're using Earth observation imagery for soil moisture, also from a surface water evaluation, looking at other climate, rainfall patterns. And I know you can also use other kind of GNSS sensor data to extract water vapor and temperature and precipitation information. So there are multiple ways to address agricultural type risks.
There's another question on cost. Not quite sure I understand it fully. It says what is cost based on time, area, your time in it? I think the question really means how does cost translate from usage to the bill for a user?
So I think the question might be related to how the INSAR cost, and it's typically Keizo from records based on area of interest, and how many images are obtained.
Yeah, it's usually like traditional business model of the satellite is basically like one image costs how much. And if you buy package, of course, there's a volume discount. As we are building constellation, or like we expect the volume data or like capacity of the observation will drastically increase. We are also we understand that we need also revisit the business model as well. So we want to work with the different partners and customers to test out our business and pricing model as well. But the basically model is like a biggest customer of the satellite, or especially synthetic aperture radar satellite, is defense customers. So there's a big demand. So similar to GPS, right? When GPS was created, it was fully funded by the military purpose. Then it becomes a commercial usage. So we have a good, market already. Then like how establishing the constellation, how to make it accessible to the commercial customers is what we are trying to, research and develop.
And we invite a good segue, Keizo. We're inviting customers, partners to engage with us to, build out these business models.
Yeah, exactly. So yeah, we are working with Insight Terra as well to seek that, options.
So would it be fair to say, and this is with my user's hat on, would it be fair to say that we can expect significant cost reduction over time?
Yeah, that's we believe that's necessary to expand the adoption.
Yeah. Great. Okay. I think probably we got time for just a couple more questions. I've got one really, which it's a bit of a. I'm going to spring it on you, Alastair. It was the last point I made in my sort of opening remarks was about this real-time integration of operational and financial data to give real-time state of the business performance, if you like. What's your view on that? Am I too far ahead of my time, or am I behind the times?
Well, look, Dave, in principle, if there's any control, any KPI or lead indicator could be, call it, plumbed if you know where the data is and you can access that data. So effectively, I think some companies might be doing that with kind of traditional business intelligence tools. But if I think about real time, what are those critical controls that you want to have real time action on or be proactive on? So most definitely, yes. I mean, we've been doing some work in other industries, more around oil and gas, where, from a well monitoring, where that's driving investment decisions around risk, reward, and safety, where it is very much a financial input is part of it. I think it's really about understanding the KPI and the control and what are the data sources that drive it, and is it worthwhile doing it in real time?
Good. Okay. There's not any more questions at the moment, so maybe there's an opportunity for. There's one. What are the levels of accuracy and precision that you can achieve in millimeters? Keizo, I think that's for you.
Yeah, so the millimeter I'm talking about is the deformation towards the satellite. So it's facing satellite. The spatial resolution is we achieved the 25 centimeters at the best case, and most of the satellites are like a 1 meter-ish, 1 to 3 meter-ish mesh. So that's the spatial resolution. Yeah, yeah.
Okay.
And
okay, just before we wrap up, then maybe the three panelists would just like to just a minute, please, just final comments on how you see the future developing.
Over to you, Jacques.
Yeah, let's go in order. Jacques, you go, and then Keizo, then Alastair.
I think the key thing is, in listening to the questions, Dave, is, historically, people, were very concerned about cost. But if you think about what connectivity, the combination of real time offer now, it makes huge difference to those people, from, reducing screen time, travel time, throwing bodies at reducing costs, etc. The accuracy in itself, almost justifies the business case more than anything else. I think we're at the pivot point of a very exciting, new developments and growth.
Is it?
Yeah, I think so. Yeah, it's really I feel exciting time that satellite is getting cheaper and more accessible. And that so we can use in more use cases like mining, monitoring mining sites and such. So and also this internet and all the connectivity allows all the data to be single place and processed by the powerful computation and the storage. So yeah, it's gonna uncover data that people have never had access, and who discover the new insights of like why the failure and the different deformations are happening. So we are really looking forward to work from the space side and the ground side. Yeah, thank you.
Super, thanks. And then Alastair, just a final thoughts on the future.
I think really what we're seeing in the last 5 years is a lot of investment in technology. So new types of instrumentation, more born in the cloud applications. So we're going to see more and more instrumentation, more and more data. It's about turning that data into value. So we're building our platform to be scalable, to support that. And I think it's going to then be how do we turn that into more and more proactive action and prevent failure, prevent these disasters from occurring in the first place, and make better accountability for directors, boards, support engineers to make the decisions and really reduce the risk. So
Great.
thank you everybody for listening.
Thanks. So, I mean, I think we'll sort of wrap up a little bit now. So, I mean, what stands out for me today really is that to extract the full benefit of these accelerating technological changes, which we see here, is that we need collaboration, such as that we've got here between Viasat, Synspective, and Insight Terra. You put all of those capabilities together, and you can actually generate something really powerful. And I do feel that we're just beginning to scratch the surface. I do hope we get some rapid adoption, particularly in the mining industry, where some of the failures to manage risk can result in the loss of life and serious environmental damage. So I'd encourage everyone to be curious and keep abreast of this dynamic evolution. And collaborative ecosystems do seem to me to be really a practical way of extracting that the most benefit. It's been very interesting. I hope it was valuable to everybody who's attending, and help us to think a bit differently about the future that we want to create. Special thanks to our 3 speakers today, and to everybody who joined us. And I'd just like to hand back to Joni now for a little bit of admin about what comes after the conclusion of the webinar. So over to you, Joni.
Fantastic. Thanks, Dave. And thank you to our speakers. And really thank you to, all the people from around the world that have dialed in. We have been recording this. We will, if you think that you have colleagues or other people that you think would benefit from some of this information, we will be streaming this live. We'll be putting this on our LinkedIn channels, so it can be watched on demand also. And we'll be sending you a little article report about this afterwards. So I guess that just leaves me to say thank you very much to everyone, and have a wonderful rest of your day.